Hello and welcome to Python in 10 session 2, lunch break session 2. Let me just get the screen share up here. Let's see, screen 2. Okay, so last time we did sessions 1 and 2. I think I originally was going to do 3 a session, but got a little long. So I'll be starting with lesson 3 here and then jump over to my other slides and then do lesson 4 in this session. And then 5 will be in part 3. Okay, so just to remind ourselves what we've already done a little bit, we introed Python in lesson 1, how to get that. Part 2 was a little longer one, was obligatory fundamentals. Now we're on lesson 3, where we're actually going to explore a large data set. So we'll use Python to parse and explore this data set. It's really useful because normal tools like Excel can't fully open a file if it's too large and it'll get cut off, but we can do whatever we want in Python. We can determine how large a file is and other basic characteristics. This is often the first step in condensing or subsetting data in a large data set for analysis in a future work. So we're going to get the data. We'll be using county distances, which are the Great Circle Distance of all counties from the National Bureau of Economic Research. Now you can find it yourself in this link here. It's from nber.org. You're going to be county distance data set. And I think for this video, I should have the description. I'll also try to have the links there. And you want to download the CSV version. So I kind of have a screenshot here, 2010, sort of infinite distances. And you can do the CSV here. It might take a while to download because it's just large. And then if you want to try it yourself, you can unzip and try to open it in Excel. And if you do, you'll probably get a warning like this with Microsoft Excel. It says file not loaded completely. It's going to be this very large data set here that's zipped. You'll have to unzip it before you open it. And it's going to have this name of something like SF12010 county distance miles. Okay, so that's doing it with non-Python. What happens if we're doing it in Python? So we're going to want to open Python. So I have my script over here, start a new file or script. You want to locate the file path for the county distances. So for where mine was, I can show this here, but I'm gonna demo it from here, because wherever you want it, you have it, you want to get your path file. So county distances, see if that'll, no, okay. Documents, go here, insertion file explorer. I think I have it in a couple places. No, county distances is not, okay. SF2. There we go. So I'm not even gonna open it because, well, if I do try to open it in Excel, it should probably give me that warning that I talked about. So I might as well just take a little time here to see if that'll do anything. Okay, not responding. Okay. Yep, it's too large for the Excel grids. I just have okay, so I'll say okay. And so pops up here and it's can show things, but I think it will cut off at a certain point. So I'll just close that down. Okay, so instead I'm going to get the file extension. You can go to open file location. I'll kind of give you where this is at. Okay, so it's right here. This is the name. If you go up here and click on it, you can get the full file extension. You can copy that and then you can put that into your place for Python. So going back, sort of trying to move around here a little bit, sorry. Okay, so what I like to do when I'm loading files into Python, I can just make this a little smaller so I can zoom this out. I like to make a variable called path and then do that full path file. And if I just, though I will need to, if I just copy the path file that I had, you can see here that it's not in quite the format we need. First of all, we need to have it in quotes. I'm just using double quotes. And then a couple other things to make it easier for, or to actually make Python read it. You need to have the slashes be doubled up. I'm just kind of doing this all just so you can see how I did it from raw to what I have created now here. Let's see. Oh, that was incorrect, I guess. Can update that. You can see here now that they're all double, and then you also want to have double at the end here. And then whatever your file name is, so this SF, I like to create a variable called file with this in quotes, as well as having the, you need to make sure it's not just the name, it also has the extension, so .csv. Okay, that's a little neater here. And of course, your full path will be different from mine because it's on your computer. Again, you can just go to where the file is located. You can get that path file right from there without having, that's probably the easiest way. So again, yep, you can also, if you have your CSV file, you can right click on it and select properties, and that'll give you the path file as part of the properties. So I have our path variable, and I have formatted, so make sure there's backslashes, and then a variable called file with the name as a string. So with that, we've got locations to our path and file. And the reason why I didn't just put this all together here, it's nice to have the path to a folder and then a file of a specific file. And so you can reuse this path if you were saying using multiple files from this folder. Okay, so we're going to open and check the file length of this file here. So I'm going to comment this and walk through what we're doing here. So I'm going to create a variable called tally. This is what I like to do, checking through things. It's pretty standard for me to do. Create a variable called tally, set it to a 0. So the tally is at 0. I'm going to start a for loop. So we talked a little bit about, I think, loops last time, or maybe we didn't. Let's double check, make sure I'm not assuming that we talked about variables. We talked about lists, math, functions. Okay, so yeah, we didn't really talk about for loops, so this is a great time to go up with that. So a for loop iterates over a sequence of things. So in a real example, you maybe use to say for each number from 1 to 10, say the number out loud. Now to actually have Python do that, you do something like this. For X in this list of 1 through 10, print X. And so for loops are really useful to iterate over things. So for example, we have a large data set and we can iterate over the lines. And so the loop we're going to create here is going to go through each line in our CSV file and add one to the tally. And so we're going to create this, having this set up here in our Python. We have 4, and we can see how different colors will be color coded in the IDL, the integrated development. Oh gosh, how do I say this? The IDL, integrated development environment. There we go. If you just have this as a text file, it will be colored. But then getting back to the for loop, so there's gonna be 4, and then whatever we want to go through. So our line, you could call this anything, you could call this X, but since they're lines, I like to do this for comprehension on the readers part of it, or the creators. So for line in, and then now we need to actually open up and use our file. So we need to use this function open, and then I can do path plus file. So that's concatenate this to have the file at this path here. If I had another file, I could say file 2, and then whatever name, if that's in the same path, I could do that here. But we're just using that first file. And of course, you could name these anything you want. Maybe you call this like county file if you have different files, and make sure you're understanding what this is going on. And this is pretty much the simplest for loop we do. So for line and open pathless file, we're going to add one to our tally out here. And then we're going to print the tally, and that's going to tell us the total number of lines. So if I actually run that, take a little bit here because it's a pretty big file. And it's taking quite a while. Yes, so we get a final count. This is the total number of lines. The number is, let's see, looking at parentheses, what, 10 million, over 10 million. There's one header line and then 10 million, 331,620 lines of observation. That's why you couldn't really open it in Excel. So that involves lines with distances from every county to every other county. So that's a lot of observations. So this is a fairly simple example of a very large data set that's helpful to use something like Python to look at. So counting the number of lines is pretty basic. Let's see if we can do anything else. What if we want to just check the first 10 entries to make sure we understand our data? So I'm going to do another for loop here, make it a little bit more complicated. So one comment, we'll talk through this. I'm going to comment out this first one, just so we're not waiting for that to run. Okay, so we're going to create another variable called tally2 set to 0, another for loop, again, for line in open, and then our file. So now what we're going to do is we're going to create an if else statement. So an if else statement is really powerful. It checks a condition and then does something based on that condition. So it could just be just an if statement. So it just does something if something is the case, and then nothing if it's not the case, or an else, which does either or. Like if something is the case, we'll do something. If it's not the case, we'll do something else. So a real world example might be if it's sunny, I'm going outside, else I'm staying inside. So for Python, you could create that by saying if variable, like equals, double equals, sunny, print going outside, else print staying in. So for our actual data set here, we're going to create a if statement here. So if tally2, and we're going to just check the first 10 entries. So the tally2, we want it to be less than 10. We're going to make sure we need to have a colon here. And I think I missed talking about this earlier, so just revisiting quick. For something like a for loop or an if statement, at the end of a for loop, there needs to be a colon. Similarly, at the end of an if or an else statement, there also needs to be a colon. So we can see over here, for statement. So really anything that starts with like this yellowish code, yellowish, I don't know, variable or special name in Python typically means that there's going to be a colon. So we're going to check for each line if the tally2 is less than 10. If it is less than 10, we're going to print that line. And then, however, if it's not less than 10, so therefore if it's greater than 10, we're going to have an else statement. And because we don't want it to keep going, we're going to use a special statement called break, which will stop the whole for loop. And then what we want to do, because if right now nothing's changed with the tally, so what we want to do at the end of the if, or after the if and else, we want to, regardless if it was an if or an else, we want to add 1 + 1 to the tally, so increment it, just like we did up here. And then what that's going to do is, so it goes through one line, it's going to check, and then print the line if it's smaller, and then it's going to add 1 to the tally. And then so the next time it gets to the next line, the tally is going to be 1 higher. It's going to do this each time until it reaches 10. And then it'll get to the point where this if statement is now false. So we'll go to the else and then fill this out and break it. And so what we should get if we run this is 1 header line, because there's a header, and then 9 observations. Okay, so we see here, yeah, great. That's what we got. We have this header, so it's county, miles to county, and then county 2. So sorry, county 1, county 2, and these are FIPS codes. Each line has a FIPS code for a county, and then so there's one county, and then the second county, and then this is the miles between those 2 counties for each of them. And so this is gonna, so for county 1, that's gonna be repeated for each of the other counties, and then the next county. And so there's every county is compared to every other county, actually twice, because you can see county 1 will be in this column, and then later on it'll also be in other columns when other counties are being compared to it. So that's a lot of observations. Okay, well, we can do more than just count the number of things or look at the first 10. Let's count our county, or your county, since you might not be in the same county as I am. So we're going to, so first of all, if you want to do this yourself with your own county, you can certainly do that by finding your county's FIPS code at the link below here. And again, this should be in the description if this is now on YouTube. So a hint for that, you can find your state first, look in alphabetical order. So let's see if I can, what was it? Control click, let's see if I can pull this up. And it's gonna let me do that. Okay. Okay, so you can, it says, yeah, you can look through. Easiest thing is to say find your state first, alphabetical order, and then go from there. So for example, mine is North Dakota, so I'd start with 3-8. So kind of scroll down till it gets to the 3/8. Oh, and it's gonna be, I think, in alphabetical. So 3/8, so that's North Dakota, and then I can find mine in alphabetical order. I'm in Grand Forks County, so there it is. My FIPS code is 3835. And of course, I've already kind of put that together here. And so what we're going to do here, uncommon, no, what happened? Uncommon, okay. So create a variable, call your own county code and set it to the FIPS code. I'm going to create this as a string, so that's why it's in quotations. I'm going to create another variable called own county tally and set it to 0, because we're going to count how many times our county is in this data set. And we're going to create a for loop, again, going through each line in our file. So for line in open, path plus file, a colon, because it's a for statement. So every for loop ends with a colon. Then we need to indent. I don't know if I've talked about indentation. Indentation is important in Python. So within this for loop, anything we want in this for loop needs to be indented by 1. So that's why the if statement is indented by 1 here. And then for anything, it's like an if else statement, the body of the statement. So this is the comparator. So if this is true, then do something else. The do something else needs to be indented. So that's why there's 2 levels of indentation. So for line, check if our own county code in that line. So again, this is what the lines look like. There's going to be 2 county codes and then a distance. So we're going to check, like, well, is 38035 in this line? If it is, we're going to add to our own county tally. And then at the very end, we're going to create a string, which is concatenating the county, Grand Forks County is in, the string of that tally, and then lines. So if we run this, should pop up down here after it's run through. It'll take a little while because it's going to run through every single line. And as we're kind of waiting here, again, we don't need an else statement. If you don't only want to do one thing, you can just use the if statement. The else is automatic and nothing happens. Okay, so we found the results. So Grand Forks County is in 7,258 lines. And actually, yeah, this is because it can happen in each line like twice as many times as there are comparisons. That's going to mean there's going to be 7,258 divided by 2, 3,629 comparisons, because half of them are going to be inverse, like Grand Forks County being county 1 versus another county, and then the other one is like Grand Forks County being county number 2, and then the other county, another county being county number 1. Okay, so we did that. That's helpful, and really, I don't, unless there's like some missing data here, this should be the case for any county you pick. Let's see, so what? Because really every county should be compared to every other one. But I'm not gonna change whatever it's Grand Forks, but let's see, let's try let's try a different county number. Hopefully this exists. Of course, if you print a own county code that doesn't exist, it should appear 0 times. So let's just check. Okay, so, interesting. So in 840 lines. Interesting. Okay, so let's just double check what that one actually was. 3038. Oh, yeah, so that doesn't actually exist. So I think that's like interesting. I think it's because the way it's set up. Let's do 3039. Anyways, it's taking a subset. It's getting off in the weeds. So let's say Griggs. I think it's Griggs. This is Griggs. So let's try that again. This should also give us the 7,000 something if we did this right. And again, this code could be cleaned up. It could be a little more precise. This is just a rough and dirty way of doing this. There's multiple ways you can, of course, do something like this. There we go. Actually, no, that is interesting. It is slightly different. Okay, so I guess maybe I was incorrect, which is interesting. Anyways, that might mean, I'm not sure what that means. Anyways, so maybe try this out on your own county and see what you get. See what you get. I guess there might be some, which means there might be some missing data. Not all counties can be compared to all counties or something like that. Or what we're having is our code is not sufficiently precise enough that maybe for some reason we're getting 38035 is not just matching to county. It's also like that for Grand Forks. Maybe sometimes it's also matching to just by chance one of these 5 decimal points here. So it might be better if we cleaned up this code to make it more precise later on, would be to actually, instead of saying, though this is it, this is a string, would probably be better is to just try to match it to the first county or the second county or both. Anyways, you can see here that there's always a better way, a more Pythonic way to do things, but I'll leave that for you. That's if you want to certainly play around and make this better. The take-home point of this is you can certainly search through large data sets for certain keywords or segments or whatever piece in your data set. And it's also important to make sure to test out, to make sure it works, to make sure it's picking up what you want it to pick up. All right, so let's keep going here to our final thing, which would be interesting, the most interesting, because this other stuff has kind of been sort of generic, oh, okay, the number of counts, all these things. But what if you want some useful information? Like you want to know how far it is from one county to another. That sounds a little bit more interesting than counting the number of times that your county founds in the data set. So actually, I think I need to. Okay, so what if we want to get our county to anywhere? So we'll determine the distance from a county to anywhere else. I'm going to, again, use Grand Forks. And I want to say, well, what's the distance to New York, New York? So that county code is 36061. You can, of course, use any other county. So that's going to be set in a variable called destination county code. We're again going to use that that for loop we've kind of perfected in this, or maybe not perfected, but use ad nauseum. For line in open path as file, colon. So now we're going to that for loop. Inside the for loop, we're going to call a new variable called distance. And we're actually going to use a method to split that line. So remember, the line looks like this. It has separated by commas. It has county 1, the distance, and county 2. We're actually going to create the variable distance is going to be the line split. And because Python starts at 0, so this would be index 0. So if we split the line by comma, so split up into 3 parts, and then index 1 is going to be the one in the middle because 0, 1, 2. So the distance is going to be that line split 1. So we want to create that as a variable. And then we're going to ask if, so an if statement, so if our own county code here in the line and the destination county code in the line, we want to print that. So we're going to say, okay, get the distance either way, but then check, is Grand Forks somewhere in here? And then is New York's somewhere in here? And if both of those are true, the and statement, so if this statement is true and this statement is true, it's going to print this out. Otherwise, it'll go through. So that's an AND is called an AND operator. If you want to just check one, you could use an OR operator, but we want the AND. So if we run this, we should get this printed statement, which is going to give us the distance that we calculate from here. If both Grand Forks, for my example, Grand Forks and the New York County is in here. Okay, and actually, you see it's odd, maybe at first blush, that it printed twice. But that's not actually odd at all, because the line should print twice, because one, for when your county is in the first column and the destination in the second. So when it's Grand Forks, then New York, then it should print a second time when the destination is first and your county is second. So when there's part one there where this is New York, and then this one is Grand Forks. So there we go. We've found in lesson 3 that Python can quickly parse through large data sets to make tallies, check variables, compare variables, etc. To do so, you can use for loops, if-else statements, mathematical operators, and other functions and methods to aid you. Of course, I just sort of breezed over things like for loops, if-else statements. You can certainly check out the following resources to dive in more details. These tutorials point to for loop and then the if-else statement. Okay. That was lesson 3, so I now need to switch over to lesson 4, and I need to close this. I think I'm just going to minimize this. Let me find my other slides. Let's see, lunch break session. Nope, that's still lesson 3. I need lesson 4. Yes, splitting data. Great. So put it over here. So lesson 4. So we just learned how to open and examine large data sets, especially ones that Excel couldn't fully open. So now let's use large data sets and discover how to split data sets into smaller, more manageable parts. First, we will break one large data set into several equal-sized chunks. And second, we'll pull out a subset of specific data from the same large data set. So that's our plan today. So we're going to the data set we're going to be using here is actually the Silva 132 eukaryotic FASTA file. It contains 18S ribosomal RNA sequences from eukaryotes. It's available alongside this presentation, and it's actually cleaned from a larger data set from ARB Silva. And so these links here should also be in the description to this video. But it's going to be a large data set. And again, so just a primer, if you're not familiar with what a FASTA file is. A FASTA file is a text-based format to represent DNA or amino acid sequences. Contains a header that starts with this greater than symbol. Often has a series of information in that header. So like, for example, maybe it'll be sequence 1, then assembly 1, maybe a unique ID. And then it'll be followed by sequence lines. And depends on the size. It may be one or many lines. And it'll be things like, so for DNA, it'll be like C's, A's, T's, and G's. If it was just RNA, the T would be a U. If it's cDNA, which is our RNA that's turned back into single-stranded DNA, that's going to be a T, not a U. And then these are also not FASTA. That's you could also have other sorts of biological data that you could do the same thing. What I'll talk about here on. You could certainly do this for protein sequences too. Though those typically, I forget if they're actually FASTA files or another kind of file. But anyways, I digress. So we're going to start by chunking your data. So we want to split that large data set that I'm talking about into 4 smaller equal-sized data sets. So you need to download that data set, the Silva 132 eukaryotic FASTA, unzip it. So I'll just kind of walk through this just because we're here. So it's not going to be, okay, so there's that. So this is from, let's go to, let's see, one second here. So there we go. Here's the zip file. So if you follow that link, I'm just going to show you what that looks like. It's going to be a pretty large file, and you can unzip it wherever you want to go. So I'm just going to extract all right here in the the downloads for now because I have this saved somewhere else, so I'll delete it after we're done here. But you want to unzip this. I'm doing this so we can also see, get another round of practice for getting that path file. So here's our file. Here's our FASTA file. And often you can open it with like something like Notepad. See if I can open that or if it's going to let me, or I'll need to use a different software. Maybe it's going to let me do that. It's pretty big, but Notepad is pretty slimmed down. It's keeping it pretty light here. It's taking a while. Maybe let's just see if we can just stop that. That might be more than we want to do right now. Really what we want to get is, there we go. Yeah, close the program. Yeah, it might eventually do that, but it was just taking so long. So again, you can kind of click here and get the path file, but I want to show you that other way I talked about. You can right click on the, kind of select it, right click on it. You can get those properties. If you want to get that's the location here. It's a little harder because you kind of have to zoom through, but you could do that. I'm gonna leave this alone here now because I think in my actual code here, I actually have it saved somewhere else. So I'm gonna make this full size. You can see, well, not quite full size. So you can screen share. This is where we're gonna have it. So I'm going to format comment. So you see here we have that path statement, and I've formatted it so it has the double slashes, has a slash at the end, and then the file name. So this is a Silva 132 eukaryotic, and it's .fasta. We'll create a tally, and I'm sure you're gonna know what we're gonna do here with the tally. We're gonna tally things and use it for good, for the forces of Pythonic good. Anyways, so that's the data set. Okay, we're gonna chunk your data. So we've downloaded the file, unzipped it, we've opened it. We have a new script here, a new file, create the path and file variables, and then we can do the tally here. And so for actual chunking, we're going to also create a title, a variable called title number, and set equal to 0, and we're going to do a for loop for each line. So let's see, one comment. So this is interesting. This is what we're going to do, a for loop so again, for loop in open path times file. So this is different from the last one because our file name is different and our path name is different. If lesson 3's, which was that Kayakos, was in the same path, you could reuse this path statement, but you'd want to rename these files something else, maybe Silva file and county file. But for here, it's keeping this simple. I just have path plus file because that's how I have it set up. So it works here. So now we're going to do an if statement, and we're going to check if the statement will have this greater than symbol, because remember, in a FASTA file, the headers lines will have that greater than symbol. So if a line has that greater than symbol, it means it's a header. Otherwise, it's just a sequence part. And so what we're going to do here is add, for every line that is the header, we're going to add one to our title number. So what that's going to say is it's going to give us the total number of sequences rather than the total number of lines, because it only counts if the line is a title. And we want to print out the number of titles, but also we want to divide that by 4 because we want to eventually break out this into 4 smaller files. So we want to know how chunky we want this to be. We should run this. It may take a while because I think, again, this FASTA file is fairly large. Okay, so we see that there is over 77,000, not lines, but sequences. And so about 19,000 sequences would be a fourth of them. So we'll round up to 19,386 as our cutoff when we get to the next step here. So chunk our data to, so we're gonna actually create things called out files. So you can read in files, but you can actually create files that you can write out to. So we're gonna create these out files. These are going to be variables. So out files, we're going to say open path. And now instead of like concatenating a file name that's already true, we're going to create a new file name. So we're going to say, call it silver1.fasta. And we need to have a comma and then a W in quotes for write. So in sort of by default, when we do this open pathless file, what this is doing here, this is by default actually reading. So the default is reading. So you don't actually have to add this argument here, but you could if you wanted to kind of keep it clear. So maybe I'll just add that here. So we realize that, okay, we're reading in this one, we're writing this one. So we're creating this new file called silver1fasta. And we're going to do this 4 times for 4 different out files. And then we're actually going to create some more things here. Whoops. Uncomment, not comment. So we're going to create a file list, which is going to be a list of those 4 different out files. And then a file number, which is 0. And then title number, which is going to be 0. So we had a title number up here. So if we set it back down here, this will reset it to 0. So then here comes the big kicker here. What we're going to do here is go through our file again. So for line in open pathos file, we can do an if statement. So we're at first if statement. So again, indenting and having the if statement end with a colon. So if the greater than symbol is in line, so that means if it's a sequence header, we're going to add one to our title number up here. And then we're going to have a second if statement. It's not nested, so this is going to do this one first and then resolve this. Then it'll go to this if statement. And then we'll check, well, if the title number is equal to 199386, and we know that's like the halfway mark, or it's sort of the 4th way mark. Within this if statement, what we're going to do is we're going to reset the title number to 0, and then file number to +1. So file number, this is going to be important here. And then we're going to print, just for our own didactic purposes, file done, and then we're going to say which file it is. And again, make sure we're, when with the title number here, make sure to use the double. This is the equal to, not the, if you do have a single equal sign, that means it's assignment operator, not the equals operator. So essentially, every time it gets to a 4th of the way through, we're going to reset everything, increase our number, say we're done, and then at the end here, so it's not nested, but it's at the same level with the if statements. We're going to file list, file number, write line. So what this is going to be doing here is it's outside the, or sorry, not still within the for loop. It's going to go to the file in the file list. And then depending on this file number, it's going to write all those files, or it's going to write that line to that file. So at the beginning here, we're going to start out, it'll write all the lines to this file. But once this happens, it's going to increment the file number, and then it'll start writing to file 2. And then once it gets to the end of that, it'll start doing to file 3, then file 4. So it'll keep doing this, and so then we'll end up with all the lines written or copied, because we're not doing anything, we're not like modifying the file, we're just looking at it. We're copying it into these different out files, each having a 4th of the data. And then at the very end, we're going to just say we're done. And now that they're smaller, we should be able to open and view the resulting FASTA files in Excel much more easily than just the one giant one. Let's see if we can do that. Yep, there we go. Okay. Oh, sorry, we forgot to take out this part, but that's fine. It's gonna just do things. File done 1. Okay, so it's 4th of the way done. Another 4th of the way done. Another 4th of the way done. Just one more file left here. Bing, we should be done, and we can go look at our new files. So again, we're gonna make sure we go to the right path. So it's gonna outright it where we created the new file. So we're in projects, what, 10%? Sorry, I just gotta look at my Okay, temp percent. Temp percent. There we go. Oh, there we go. Should pop up here. Okay. And okay, so these are the silver files here. We see this is the big one. So it's, you can see it's 146,000. We can see that the smaller ones are about a fourth of those each. We should be more easily able to open these up. Again, you can do this Excel. I just used, I guess, clicked by default Notepad. We'll see if this will do any faster in loading. Okay, well, we'll let that be for right now because we'll talk about what's going on here. It's not responding, but we'll see. You know, actually, yeah, okay. Why don't we do something a little different? We will open this with Excel, like I talked about. Right-clicking, open with, let's try Excel. And now this should be small enough to be able to see in Excel without it being sort of cut off early. So as we sort of let that load, again, so I'm gonna close the other one I had out here. There we go. There's a file, and we can see here now that we have our data, we have our header, and then these are lines of the RNA. You can see AUs, GCs. So there we go. That was kind of nice. All right, take-home points here. What are the take-home points? The summaries, as it were. Well, our code counts titles and writes lines to the first out file until it reaches the cutoff value, 1/4 of the total title number. Then it resets the count, switches it to the next out file, and continues. In the end, there are 4 out files produced, each one with the same size. The 4th out file has 1 less title number because we had to round, because it wasn't perfectly divisible by 4. It was like 3/5. What was it like? Oh yeah, 198,385.25. Okay, so that was kind of nice. Okay, chunking into smaller bits, but maybe we want to do something a little better. What if we want to subset your data by criteria? We only want to look at a certain subset of data. Well, we can certainly do that, and that's what we'll close our time with here. Okay, so format, comment out. Okay, so we still need our path file. We'll keep that here. Format, uncomment, right? Okay, yes. And so it's going to be all this subsetting here. So all the data will run, format, uncomment. We'll talk through what this does momentarily. All right, so what we want to do for this part, our goal is to create a subset of the data based on criteria from the titles. So those sequence faceted titles has a lot of information. So first of all, we want to subset the title only. Right, okay, that's going to be our first task, sort of the simplest one. So we're going to create another output file. I'm going to call output file 5, open, or I mean, I'm going to set it to a variable called output file 5, but then actually the name of it, which will be created on the computer in that, the path file, the path folder will be silver_chordate.fasta. Again, we need to have the right option here with W. So we're going to say 4-line open path post file. So we're going to check the line. So if chordata in line, so chordates are animals with chordates, so vertebrates, so backbones and closely related kin, because this is all eukaryotes. So those are things included in vertebrates and everything. We just want the chordates. So we're going to say, well, look in each line. Now, if it's a sequent line, it's going to be A, C's, U's, and G's. So it's not going to have chordate in there. And non-chordates will not have chordate in there. So only titles with chordate in there is the ones we want. So what we're going to say, if chordate's in line, so indent, we're going to outfile.write that line. We've kind of seen that a little bit. So this is a method. So we're going to apply this method to outfile, our outfile here that we've created, and then we want to write that line with the chordate in it. We're going to close that, and then, you know, we want to know when we're done, so we're going to print out the file's done. So we'll take a look at that in a moment. I want to Okay, so that's here, but I want to keep going and do a little more sophisticated version in our output file 6 before we look at both of them. So just getting the names are okay, but we probably also want the sequences. So we want to subset how n sequences. So we're going to have to do a little bit more. There's different ways of doing this. This is the way I sort of set up to do. So we're going to create a final output file that we're just call output file 6. I'm going to call it Silver Chordate Full Faster to distinguish from this one, which just has the titles. And we're going to create a variable, which is a Boolean called chord switch, and set to false. So this is what acts as our switch in our later for loop. When the switch is on, we'll write to our out file. When the switch is off, we won't write. So we'll see how that works here. We'll create the for loop for line open path of file. So if the greater than symbol is inline, that's our first if statement. So, which means is once we get to a title, so again, all the titles have the greater than symbol. So if we get to a title, we want to do something. And we'll have a nested if statement within there. Actually a nested if else statement. So we're going to say, well, if it's a title, if the title has chordate in the line, so it's both a title and a chordate, we want to turn the chordate switch to true. Otherwise, the switch is set to false. So it's if it was true before, it's now set to false. If it was false, it continues to be false. So that's the first if statement. It's determining what the line is, whether it's a chordate or not. And so then we're going to do an if statement. So it's not nested in here. It's on its own line here. So it'll resolve after this if statement. So if chord switch, so equivalent, we could make this a little more wordy. We could say chord switch equals true. But if you just say if chord switch, by default, that's equivalent. And then what we want to do is output file 6, yeah, write line. And then at the very end, we want to close our out file. Actually, I think we need to also close our out. Oh, no, we did close our out file here. We want to close out file 6 and then print that it's done. And so what this is going to do here is this switch is very interesting is if the switch is off, it doesn't write anything. If the switch is on, it'll write. So it'll write the chordate line when we get to there, and it'll keep writing those sequence lines behind it until it gets to another header. And if the header is a chordate, well, it'll keep on going. But if it's not a chordate, it'll turn it off, and so it won't do any of those lines. So we did our job correctly. We should have some very interesting file. Okay. Oh, right. Okay. Yes, I forgot to uncomment this. That's why I couldn't find what I was talking about with file. It was saying what? Because it was not defined. Okay. So we're going to start with the simpler one, which is going to be just that smaller chordate file. That should turn out. Okay, it's working, it's thinking, okay, that's done. Now it's gonna go run this one. Hopefully. All right, so let's go to our temp%. I think that's where I have, I have my file too. Why is it not showing up? Oh, is it behind something? Sometimes no, it's not behind something. Where is it? All right. There, did we find it? Okay. So we had those Silva. Okay, Silva chordate faster and full. So this is the smaller one. I think we should be able to do Notepad for once. For once this time. Yes, there we go. And so we see here, all it has is all those chordate headers. So greater than symbol, it's a header. We can see here that eukaryotic, there we go, there's chordate. So any lines, only the lines with, you see every single line has chordate because it's the only ones we wanted. Okay, so this is the full one. This is somewhat larger. It's about 10 times larger because for every title, for every header, there's going to be about 10 lines of sequence data. And so that's a lot better. It's probably more useful to have, okay, we have these are Homo sapiens. So this is the human 18S. Here's the more human. Let's go find some more interesting things. I have no idea what that is. These are fish. So I think so. Actinopterygii. I think there's some sort of fish. Oh, hey, look. Oh, sweet. Oh, we missed it at some point. There was a goblin shark DNA or RNA. That's sweet. Okay, so we got that. And so you can see here, to try to do that by hand, to like go through all this huge file and like pull out just the chordates would be a huge task. It would take forever. But with a couple lines of strategically selected and intelligently designed code, or even messily but gets the job done code, as mine usually is, you can really quickly pull out a lot of data from a large data set. All right, to summarize, we can split or subset large data sets. We can make smaller chunks or subsets to new files. We can write new files with that data using for loops, if-else statements, and other functions to aid you. It's very useful for things like genetic data, which can be huge, but you can think of all sorts of large data sets that this would be applicable for. Well, with that, that is all I have for lesson 4 today. Thank you for joining me. Hopefully this was helpful.